For more than half a century, the Boeing 747 was the airplane people imagined when they pictured long-distance air travel. Its upper deck hump, 4 engines, and enormous wings made it instantly recognizable, even to people who knew nothing about aircraft. It was nicknamed the Jumbo Jet because, when it entered service in 1970, nothing in airline service looked remotely as large. But the 747 was not built simply to impress. It was created to solve a business problem. Airlines needed to carry more people farther, while lowering the cost of each seat. In doing that, the 747 helped make international travel more accessible, reshaped airport infrastructure, and became both a passenger icon and one of the most successful cargo aircraft ever built. The story begins with Pan Am, one of the most influential airlines of the jet age. By the early 1960s, Boeing's 707 had already transformed global travel, but demand was growing fast. Pan Am wanted an aircraft more than twice the size of the 707, with the goal of cutting seat costs by around 30%. That was a bold request. Larger aircraft could spread fuel, crew, and operating costs across many more passengers, but building one required new engines, new structures, and a new way of thinking about airports. In 1965, Boeing engineer Joe Sutter left the 737 program to lead the 747 design team. The schedule was aggressive, the financial risk was huge, and the airplane had to work from the start. In April 1966, Pan Am committed to 25 Boeing 747-100 aircraft, giving the project a launch customer and a reason to move at full speed. But the airplane needed more than a stretched fuselage. It required powerful high-bypass turbofan engines that could lift a wide-body airliner efficiently over long distances. Pratt & Whitney agreed to develop the JT9D engine, one of the key technologies that made the aircraft possible. Boeing also needed somewhere to build it. The result was the purpose-built Everett plant in Washington state, a factory so large it became known as the world's largest building by volume. On September 30, 1968, the first 747 rolled out, looking less like a modified jetliner and more like a new category of machine. The 747's first flight took place on February 9, 1969, and certification followed in December of that year. Pan Am introduced it into service on January 22, 1970. The timing was remarkable. In only a few years, Boeing had gone from concept to one of the largest and most complex commercial aircraft ever produced. Passengers entered cabins that felt radically different from earlier jets. A typical three-class layout carried around 366 passengers, and economy seating could be 10 abreast. The aircraft's scale changed the atmosphere of flying. It was not just faster travel across oceans, it was mass long-haul travel. The 747 helped turn routes that once felt exclusive into services that could carry hundreds of people at a time. One of the most distinctive features of the 747 is its raised cockpit and partial upper deck. That hump was not originally just a style choice. At the time, many believed supersonic transports might eventually replace large subsonic passenger jets on premium long-haul routes. Boeing wanted the 747 to remain useful if that happened, so the design allowed the aircraft to be converted into a freighter with a front cargo door. Placing the cockpit above the main deck made it possible for cargo to be loaded through the nose. This decision gave the airplane its iconic profile, but it also helped explain why the 747 survived so long. Even when passenger demand shifted, its cargo capability remained extremely valuable. Technically, the 747 was built around a combination of size, speed, and structural strength. It used 4 engines, beginning with Pratt & Whitney JT9DS, and later variants used General Electric CF6 and Rolls-Royce RB211 engines. Its wing had a sweep of 37.5 degrees, allowing a cruise speed around Mach 0.85, roughly 900 km per hour. That made it fast for such a large aircraft. Its weight was distributed through 4 main landing gear legs, each with a 4-wheel bogie, which helped spread the load on runways and taxiways. Everything about the airplane had to balance competing needs: enough capacity to transform airline economics, enough range for international routes, and enough reliability to become a daily workhorse. The first production model, the 747-100, proved the concept, but Boeing quickly began improving it. In 1971, the 747-200 arrived with more powerful engines and a heavier maximum takeoff weight. That increase was not just a number on a specification sheet. A heavier takeoff weight meant the aircraft could carry more fuel, more payload, or both. The maximum range rose from about 4,620 nautical miles to as much as 6,560 nautical miles, depending on configuration. This mattered because airlines wanted the 747 not only on dense transatlantic routes, but also on longer international services where non-stop capability could attract passengers and simplify operations. Boeing also experimented with shape and capacity. The 747 SP, introduced in 1976, was a shortened version designed for longer range. Its shorter fuselage gave it a distinctive look and allowed airlines to operate ultra-long routes that were difficult for the standard 747 at the time. Then, in 1983, the 747-300 introduced a stretched upper deck, increasing passenger capacity and making the hump longer and more graceful. The upper deck, originally a small lounge-like space on early aircraft, became a more practical seating area. Each version reflected the same basic question: how could Boeing adapt the 747's huge platform to different airline needs without losing the advantages that made it famous? The most successful version was the 747-400, introduced in 1989. It represented a major modernization rather than a simple update. The aircraft offered improved engines, including upgraded RB211 and CF6 options and the newer Pratt & Whitney PW4000. It also introduced a two-crew glass cockpit, replacing older flight deck arrangements that required a flight engineer. Better avionics, improved efficiency, and extended capability made the 747-400 the dominant long-haul flagship of many major airlines. For years, if an airline wanted to project global reach, the 747-400 was one of the clearest symbols available. It carried holiday travelers, business passengers, heads of state, and cargo across the world's busiest international corridors. The 747's role extended far beyond ordinary passenger service. It became the basis for major government, military, and scientific aircraft. The VC-25, known to the public as Air Force One when the U.S. President is on board, is based on the 747 platform. The E-4 served as an emergency airborne command post. Modified 747s carried the Space Shuttle, acting as shuttle carrier aircraft. Others became experimental platforms, including the YAL-1 airborne laser aircraft and SOFIA, a flying observatory designed for infrared astronomy. These special versions show why the 747 was so useful. It had size, range, structural capacity, and electrical and systems potential that few other aircraft could match. Competition changed throughout the 747's life. In the 1970s, smaller wide-body trijets such as the McDonnell Douglas DC-10 and Lockheed L-1011 offered airlines lower-capacity alternatives. Later, the MD-11 and Airbus A340 competed on long-haul routes. In the 2000s, Airbus surpassed the 747 in size with the A380, an even larger double-deck passenger aircraft. But the bigger threat came from twin-engine jets. Aircraft such as the Boeing 777-300ER and later 777-9 could carry large numbers of passengers with only two engines, lower fuel burn, and simpler maintenance. As engine reliability improved and long-range twinjets became more capable, the economics that once favored four-engine giants began to fade. Boeing launched the final major version, the 747-8, in 2005. It used General Electric GEnx engines, related to technology developed for the 787 Dreamliner, and the Dash 8 name reflected that connection. The 747-8 was stretched and modernized, with both passenger and freighter versions. The passenger model found only limited airline demand, but the freighter version remained important. Cargo operators valued the 747's nose-loading capability, large volume, and ability to carry outsized freight. This is one reason the aircraft remained in production long after many airlines retired their passenger 747s. Even as the passenger era narrowed, the 747 still filled a role that newer twinjets could not completely replace. The final Boeing 747 was delivered to Atlas Air in January 2023, ending a 54-year production run. In total, Boeing built 1,574 aircraft. By then, the 747 had become more than a product line, it was a chapter in aviation history. It helped democratize long-haul travel, forced airports to adapt to wide-body operations, and proved that very large aircraft could be reliable commercial tools. Its record also includes tragedy. As of October 2025, 65 Boeing 747s had been lost in accidents and incidents, with 3,746 deaths. But its broader legacy remains immense. The 747 was born from a demand for lower seat costs and became the aircraft that made the world feel smaller. If you found this helpful, please like this video and subscribe for more explainers.